doing simplifying rationals, once again, it's an easier lesson than the ones coming up. So you have to really know what you're doing for these ones, because we really want to get the easier lessons down really, really well, so when we get to the harder ones, that they're not as bad. So it says reduce the following fractions. So if we want to reduce a fraction 8 over 12, we have to decide what can we take out of the top and out of the bottom that's the same. So we can take out a 4. So we divide the top and the bottom by 4, and we get 2 out of 3. Now yesterday we did equivalent rationals, so as long as we did the same to the top and the bottom, whether we multiplied or divided, it was fine, right? But when you simplify, you're making simpler. So you can't multiply the top and the bottom by the same thing and say you're simplifying it. You're making it bigger, right? That's not helping. That's not simpler. So whenever it says simplify, you have to divide the top and the bottom by something that's the same. You can't multiply. That's equivalent. So 45 over 63, what can I take out of both of them? 9. I get 5 out of 7. And then 12 and 36, what's the biggest thing I can take out of them? Starts with T, rhymes with welve. Still no answer? Of course, of course. See, it's not going to be good. 12. So 1/3. So steps to simplifying rational expressions. So the first thing you want to do, so those are just basic fractions. Once we go to rationals, we have to follow certain steps. We take out common factors, GCFs where possible in the numerator and the denominator. We also check for difference of squares. So we see if we can take out GCFs, and then we also check for difference of squares, because those are the only things that we can do to simplify it, okay? Before you cancel anything off, before you say, hey, this is common in the top and the bottom, and you cancel it off, you have to state non-permissible values first, because you have to state non-permissible values for any value that was there or still is there. So before you cross off, you have to state NPVs. If you do it after, you might miss a non-permissible value, okay? So before you cross off, you slap your hand and you say, no, must find NPVs first. Yay. What is... All right, so we need to find them before we cross off, and then when we're done, once we stated our NPVs, then we can cancel off anything on the top and the bottom that's the same. If anything is attached by a plus or minus sign, remember they're attached in brackets. It's like a head, feet, and a body in the middle. You can't cut them in part. If they're attached by a multiplication sign, then you can put them in their own brackets, right? But addition and subtraction signs, you must put in their own brackets. They're attached together. So these are all multiplied together, correct? So I could rewrite this as 12 times x cubed times y. And then on the bottom, we have 36 times x squared times y squared. Because they're all multiplied separately, you can write them that way. Now, before we go to cancel anything off, we have to state NPVs. Whenever you have an x or a y by itself, all you have to say is x can't equal 0 and y can't equal 0, because they have nothing attached to them. So once we stated our NPVs, we can cancel off what's common. So the 12 and 36, is there anything I can take out of both of them, just like I did the fractions above? 12. If I take a 12 out of 12, I'm left with a 1. If I take a 12 out of 36, I'm left with a 3. Now what about the x cubed and the x squared? Mason, what can I take out of them? 2 x's out. So an x squared out of here, and then I'm left with 1 up top, right? McKinley, what can I take for y's? Just one of them. And I'm left here. Now I can just write what's left over. So I have 1 times x1 times 1. So technically on the top I just have x. And on the bottom I have 3 times 1 times y. So just 3y. And I'm done. You try B and C. Okay, let's go through them. So we can write this one as negative 24 times a squared over 18 times a cubed. Now if I just have an a cubed on the bottom, I can say a can't be 0. So I always take my NPVs before I cancel. 24 and 18, what can come out of both of them, Alexis? Yeah, 6. If I take a 6 out of negative 24, I'm left with negative 4. If I take a 6 out of 18, I'm left with 3. Then Grant, what can I take out of a squared and a cubed? Yes. So I can take them, 2 a's out of there, and then 2 a's out of here. I'm left with a 1. And so on the top, I'm left with negative 4 times 1, which is negative 4. And on the bottom, I'm left with 3a. Then I have 18 times x4. Remember, when they're multiplied, they can go in separate brackets. 36 x7. So what can I take out of the 18 and the 36, Joe? An 18. So if I take an 18 out of 18, I'm left with 1. And an 18 out of 36, I'm left with 2. And Paige, what can I take out of x4, x7? So I can take an x4 out of here and an x4 out of here. I'm left with 3 of them. So on the top, I have 1 times 1 times 1, so 1. And the bottom, I have 2 times x cubed. What did I have to make sure I did before I crossed off? State NPVs. So before I crossed off, I should have hit my hand and said, no, don't get too happy that you can cross things off. Make sure you state NPVs. Luckily, my x is still around, but if it wasn't and I only stated NPVs after, I wouldn't say that there was any, right, which is a problem. So I always have to state them before I cancel. So if I have a single x by itself, it's going to be x can't equal 0. Okay, next page. Okay, so those were monomials. Monomials means no plus or minus signs, right? They're all attached by multiplication signs. So monomials are easier to simplify. Now we have binomials and could possibly have trinomials, but for the most part we have binomials. Binomials means 2 terms connected with a plus or minus sign, okay? So the very first thing we want to do always is say, can I take out a GCF out of the top or bottom, or is there a difference of squares per chance in the top and the bottom? Those are the 2 things we're going to look for. Every single time we have to simplify if it's not a monomial. So in the top, 9x squared minus 2x. What could I possibly pull out of there, Julia? An x. Because no numbers can come out of 9 and 2, right? Just an x. So we take out the x. And we pull an x out of these 2 terms, 9x squared divided by x, I'm left with 9x. Negative 2x divided by x, I'm left with minus 2. Now this x out here is in brackets by itself because it is being multiplied by the 9x minus 2. And the 9x minus 2 is in its own brackets because it's all attached with that minus sign, right? So I can only get rid of 9x minus 2 if there's a 9x minus 2 on the bottom. If there was a 9x minus 2 on the top and a 9x on the bottom, they'd both stay. The only way that that 9x minus 2 is going away is if it is exactly replicated on the bottom. When they're attached to the plus or minus sign, that is one term. Okay? Luckily, if we look, what happens? We have a 9x minus 2 on the bottom. Now, this usually makes people extremely excited because they see something matching and they want to cross it off. But before we cross it off, what do we have to do? State. What do we have to do before we cancel? Stuff and things. State NPVs? Yeah. So we take what's in the bottom, once it's simplified, and we go off the side and we say 9x minus 2 can't equal 0, just like we did yesterday. So we have NPVs. Then what do we move? 3? The 2 over. So we're going to add the 2 to both sides. Then what do we do, Brittany? By that 9 over, so we get 2 over 9. So x can't equal 2/9. If it did, we'd be in trouble. Okay? We always have to say NPVs, and like I told you on the diploma, there will be an NPV question. There has always been an NPV question. Now this time maybe there will never be because I just said there will always be, but there's a really good percentage chance, probability that there's going to be an NPV question. And it's always been multiplication or division, which we'll go over soon. So now once we stated NPVs, we can simplify. We can cancel off stuff that matches. Now some people will say this, if this wasn't 9x minus 2, some people will say, well, I can cross this x off with this x. Remember, 9x minus 2 is attached in a bracket. The only way it is going anywhere is if there's an exact replica on the top and the bottom, which there is. So this one cancels. So I'm left with an x on the top. Do I have to write over 1? No. What happens if it was like this, though? Don't write, just watch. What happens if it had been switched? It was 9x minus 2 over x, 9x minus 2. And the 9x minus 2 is canceled. Could I just write x? No. If there's a 1 up here, I have to write it. Because 1 over x is much smaller than just x, right? So if it's just a 1 in the denominator, I don't have to write it. But if there's a 1 in the numerator, I have to. It's not just x. Okay? So make sure you do that. Let's look at B. So when simplifying, I ask myself, is there something I can take out of the numerator, the top? 3 and x. Is there anything I can take out of the numerator? It would just be 3 and x, right? Because there's no plus or minus signs. If there's no plus or minus signs, it's just 3 times x. So I can write them in their own separate brackets, right? In the bottom, is there anything I can take out? Teresa? You take out an x. When you take an x out, you're left with x plus 6. And this little x in front can go in its own brackets too because it's being multiplied. Anything that's multiplied can go in its own brackets. How many NPVs am I going to end up with? It's 2. So I'm going to end up with 2 NPVs. I have to take this x that's by itself and say x can't equal 0. And then I have to take x plus 6 and say it can't equal 0. Well, x can't equal 0 is done already because I don't have to solve for x. It already is solved for x. But the x plus 6, I need to move the 6 over. So I'm going to subtract the 6. And I'm going to have x can't equal negative 6. So I can write them together. X can't equal negative 6 and 0. Once I've simplified or GCF or difference of squares, and I did NPVs, now I can cancel if there's anything common, right? So on the top I have an x, and on the bottom I have an x, so I can cross them off. Now this is where people feel like sometimes it needs to be more simplified than it is, okay? So some people say, well, I have a 3 on the top and a 6 on the bottom. So I can take this 3 and I can cross it off and this becomes a 2. No. Remember I said if it's attached by a plus or minus sign in its own brackets, the only way it's going anywhere is if at the top there's the exact same thing. So on the bottom I have x plus 6. It is going nowhere because there is no x plus 6 on the top, right? So that's as simplified as it can get. It's 3 over x plus 6. Don't try and make it more simple than it is. It has to match exactly. Yeah. Yes, if there's an x minus 6 on the top and an x plus 6 on the bottom, they would just stay, right? And it's yes, because x minus 6 and x plus 6 don't match. So C, first thing we ask ourselves is, can we take anything out of the top and the bottom? Are they a difference of squares? Parker, can I take anything out of the top? 6xy. So if I take a 6xy out of this first term, out of 6x squared y, I'm left with x, plus 12 divided by 6 is 2, xy, they cancel. So I'm left with x plus 2. Now that 6 and that x and that y are all multiplied by each other, so they can go in their own brackets, right? Anything that's multiplied, not attached to the plus or minus sign, can go in its own brackets. On the bottom unicorn, what can I take out? See, he knows. I can take out an 8x. And when I take an 8x out of 8x squared, I'm left with x. 8x out of negative 8x, I'm left with negative 1. And that 8 and x can go in their own bracket. Now this time, Caitlin, how many MPVs are there going to be? 2. Because that 8 isn't an MPV, it's just a number, right? So the 8 can't become 0 because it's 8. So we're going to have to go off to the side and we'll do x can't equal 0. And then that one's done already because it's solved for x. And then x minus 1 can't equal 0. So x can't equal 1. So I have x can't equal 0 or 1. Now, why is there anything in the top or the bottom that I can take out? No letters on the top that match. Yeah, x. So I can take an x out of the top and an x out of the bottom. Can I take this x out with this x? No, this is x plus 2. It can only go away if there's an x plus 2 on the bottom. This is x minus 1. It can only go away if there's an x minus 1. So those are staying forever because there's nothing that matches them. What about the 6 and the 8? That's like those fractions we did right at the beginning. Can I take anything out of the 6 and the 8 because they're by themselves? I can take a 2 out, right? Just like we did those fractions that were by themselves at the beginning. I can take out a 2. So 6 divided by 2 is 3, and 8 divided by 2 is 4. So on the top, there's nothing more that I can take out of the bottom. So I'm left with 3 times 1 times 1 times y times x plus 2. So it'd be 3y x plus 2. And if you want to keep those 3 and y in their own brackets, that's fine. But for the final answer, you don't have to. And then 4 times 1 times 1 times x minus 1 is 4 times x minus 1. And that is as nice as it gets. It's not going to get any prettier than that. Okay? I want you guys to try D, E, and F. D, E, and F. Okay, so for D, the top, the numerator, what can I take out of the top, Grant? What can I take out? Yeah. No. Pardon? 3y? It's hard because 3y is correct. So this is the catch though, you guys. If you take a 3y out of 3y, what are you left with? 1, not 0. If you cross them off and you said you were left with 0, put a little note and say, don't do that. Bad. Okay? It happens a lot. So if you did make it a 0, you are probably of 70% of this class. Okay? You're not the minority, you're the majority. So 3y divided by 3y is 1, not 0. And you have to have that 1 there. It's a placeholder. Then negative 9y squared divided by 3y is negative 3y. So if you just had negative 3y there and didn't have the 1, put a little note to yourself and say, make sure that when you divide by itself, you're left with a 1. On the bottom, you have 6y cubed. It's a monomial, no plus or minus signs. So what I'm going to do is I'm going to go back and put brackets around anything that's multiplied. Now I have just a y by itself, so the MPVs are easy. It's just y can't equal 0. Now I can cancel off. I have a y on the top by itself and a y cubed on the bottom. I can take a y out of both of those. So I'm left with y squared. Then I have a 3 and a 6, just like at the beginning with those fractions. What can I take out of a 3 and a 6, Bree? 3. So on the top, and then I have a 1 minus 3y on the top. The only way it's going away is if I have a 1 minus 3y on the bottom. Do I? No. So it's staying for the long haul. So 1 times 1 times 1 times 1 minus 3y is just 1 minus 3y. I don't have to put it in brackets. It could just be up there by itself now because it's the only thing. And then a 2y squared on the bottom. E, 6m squared minus 8m. Teresa, what can I take out of 6m squared minus 8m? A 2m. And then I'm left with 3m minus 8m divided by 2m, 4. And then the m's cancel. And then on the bottom, I can take out an m squared. 3m cubed divided by m squared is 3m. Negative 4m squared divided by 4m is negative 4. And when people see 3m minus 4 over 3m minus 4, they want to cross them off right away because they're so excited that they match. But remember, we have to state NPVs first. These are in their own brackets. So we have m can't equal 0 because of the m squared by itself. And we have 3m minus 4 can't equal 0. Move the 4 over. 3m can't equal 4. Divide by the 3. And m can't equal 4/3. So I could say m can't equal 0 or 4/3. Now, Mason, what can I cancel off? The 3m minus 4th. Then you can take out 1m. And so then we're just left with 2 over m. Yeah. F. Caitlin, what can I take out of F? The top, the numerator. 3a2. So I can take a 3a squared out, and I'm left with 3a cubed divided by 3a squared, an a. And then negative 3a squared divided by 3a squared is minus 1. On the bottom, Julia, what can I take out? If I take out a 12, then I'm left with negative a plus 1, and I need it to be positive a minus 1 so that they cancel. So instead of taking out a positive 12, maybe I should take out a negative 12. So if I take out a negative 12, I'm left with positive a, and then positive 12 divided by negative 12 minus 1. And now they match. And if you were to take out a positive 12, you'll catch that you might catch there the opposite sign and go back and take the negative out after. Okay? Now we can put the ones that are by themselves in brackets. And negative 12 doesn't give us an NPV. A minus 1 does. A minus 1 can't equal 0. A can't equal 1. Then our a minus 1s cancel. There's an a squared by itself on the top. Nothing's going to happen to that. But the 3 and the 12, I can take a 3 out. 3 divided by 3 is 1. 12 divided by 3 is 4. So I'm actually left with 1 a squared over negative 4. So I can write it as a squared over negative 4. This is also the same as negative a squared over 4. I could put the negative out in front. Or I could put the negative with a squared. Those are all the same answer. The catch is that there's only one negative sign. So you can't put a negative on more than one of the things, right? But the negative can move around. G. G is x minus 2 and 2 minus x. This happens a lot where you have to spot that they're the wrong sign. So what I always do is I try and write them x first, or variable first. So x minus 2, and then on the bottom, I have negative x plus 2. The top and the bottom are the exact same variable, letter, and number, but wrong signs, right? On the top, I have positive x. On the bottom, I have negative x. On the top, I have negative 2. On the bottom, I have positive 2. So what can I do to the bottom? Pull what out that will make the signs change? What do you think? I don't want to pull out any numbers because I can't. I don't want to pull out any letters or variables because I can't. But I can pull out a negative 1. If I take a negative 1 out of the bottom, it will change the signs of everything in the bottom. So the top is x minus 2. And in the bottom, I can pull out a negative 1. If I take out a negative 1, my negative x becomes positive x. And my positive 2 becomes negative 2. And now they match. So if you have everything the same, letters and numbers, but the signs are opposite, you can just pull out a negative 1. Now I can state MPVs. Negative 1 isn't going to do anything. X minus 2 will. So I have x minus 2 can't equal 0. X can't equal 2. Why not add that 2 over? And now I have a minus 2, x minus 2, and an x minus 2. So I'm left with 1 over negative 1, which is just negative 1. H. Is there anything I can do to the numerator, the top? Is there anything I could take out of x plus 6? No. So we can rewrite it as x plus 6 in bracket. The bottom, x squared minus 36. Is there anything I can take out of that? No. But what is it? Difference of squares. We can't forget that we also have the option of difference of squares. So GCF or difference of squares. How do we know it's a difference of squares? Well, it has a difference sign in between, subtraction sign. And x squared is a perfect square. When I take the square root of it, I get x. When I take the square root of 36, I get 6. So I now can get x in the front, 6 in the back, opposite signs. So what do most people forget? That difference of squares even exists, okay? So don't forget that it exists. Now I'm going to get 2 MPVs. I get x plus 6 can't equal 0, and x minus 6 can't equal 0. Move the 6 over, I'm going to get x can't equal negative 6. Move the negative 6 over, I'm going to get x can't equal positive 6. And then we can put them together. X can't equal plus or minus 6. Parker, is there anything I can cross off? Yeah, the x plus 6. Yeah. So if I cross off the x plus 6's, am I just left with x minus 6 as my answer? Just x minus 6? No. What's left on the top? 1. So I'm actually left with 1 over x minus 6. You try I. At the top, you have to remember you can take out a 3. You're left with x minus 2. The bottom is a difference of squares. X squared is x. 4 is 2. So I'm going to get x in the front, 2 in the back, plus, minus. So I get x plus 2, x minus 2. X plus 2 can't equal 0. X minus 2 can't equal 0. And X equals negative 2. And X can't equal 2. So X can't equal plus or minus 2. Then the X minus 2's cancel. And I'm left with 3 over X plus 2. Ta-da! This multiple choice question down here says which of the following rationals is simplified. So you have to tell me, it's a multiple choice answer, which of the following 3 are simplified. So try that one out. All right, which rational expression is simplified? So the top one, I can take a 2 and an X out, so it's not simplified. The second one, I can't take a number out and I can't take an X out because it has to come out of all of them, right? And it can't. So it is simplified. And then this one, I can take a 5 out of all 3, so it's not. So it would just be 2. Which of these are simplified? So I can't take a number out of all 4 of them. And I can't take a letter out of all of them. So it's simplified. This one, I can take an X out of all of them. So that means it's not simplified. And this one, I can't take a number out or a letter out of all 3 terms. This one, and this one. So it's simplified. So it's 1 and 3, which is D. 81s squared, 36s. Well, we know that it's going to be 81s squared over 36s. We know s is going to be equal to 0. I know that I can take an s out of both of these. And what can I take out of 81 and 36? 9. I've taken 9 out of 81 and left with 9, and 9 out of 36 and left with 4. So it's 9s over 4, which is C. Example 6, the top, I can take a 3 out. Take a 3 out of 3, I'm left with a 1. Plus a 3 out of 18, I'm left with a 6p. And then on the bottom, 36p squared. I have a p by itself, so p can't equal 0. You can take a 3 out of the 3 and the 36. 36 divided by 3 is 12. 3 divided by 3 is 1. And then I can't cancel anything else off. So I'm left with 1 plus 6p over 12p squared. A. And then example 7. Example 7 on the top, I can take out a 5 and a b. And then I'm left with 3. 15b divided by 5b is 3. And then 50b cubed divided by 5b is 10b squared. Over. The bottom, I can take out 5. B. Again. And then I'm left with 4b squared minus 9. Cancel, 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 cancel. It's going to be A. The catch on this, though, is that this should be 0 and plus or minus 3 halves. This should be a positive negative. It should be B can't equal 0 or plus or minus 3 halves. Because when you solve 4b squared minus 9 out for NPVs, you're going to get 4b squared minus 9 can't equal 0. 4b squared can't equal 9. B squared can't equal 9 over 4. Square root it. And when you take the square root, you take plus or minus unless it's 0, remember? And the square root of 9 is 3, and the square root of 4 is 2. So it's plus or minus 3 over 2. They oopsied. No.